Welcome to another episode of our video here on the Orlando Redhound YouTube channel. We will be discussing subsets and their relation to other sets, particularly the power set. So subset is the set that contains at least one element of the other set under consideration, which of course includes the null set. If we have set A, which contains three elements, 1, 2, and 3, the subsets are the sets that contain at least one of these elements, including, as we said, the null set or the empty set. We can see that set A has 3 elements as shown, and it has 8 subsets. To find the number of subsets a set contains, we can use the formula 2 raised to n, where n is the number of elements the set under consideration contains, where in this case set A. So let's try finding the subsets of set A using the given formula 2 raised to n, where in this case, n is equals to 3 since there are 3 elements in A. So we replace n with 3 and calculate the result. And as expected, we got 8 subsets as shown. At this point, it is important to note that subsets in this discussion were formulated based on the elements of set A. And set A is called the superset of these subsets. Let's take another example. If we have set C with the elements as shown on your screen, we can calculate how many are subsets by using the formula 2 raised to the power n, where in this case, n equals 4. Or there are 4 elements in set C. Since n equals 4, we replace n in the formula with 4 and proceed to calculate. And we find that there are 16 subsets of set C. Writing all 16 subsets are tedious. Not unless you have the technique of enumerating them all in an orderly fashion. And that is exactly what we are going to do. First, we only consider the first 2 elements B and C. And there are 4 possible subsets with only 2 elements as shown. Then to every subsets we add element 1. Again we add element 3 to all the existing 8 subsets. Now we got all 16 possible subsets of set C. All of the subsets are proper subsets, except the one with exactly the same elements as set C. This subset is called improper subset. And again, the superset of all of these subsets is set C. Here we see that there are 2 types of subsets, the proper subset and the improper subset. And as a consequence, there are also 2 types of supersets, the proper superset and the improper superset. And the symbols used to denote these sets are as shown. Proper subset, the improper subset, proper superset, and the improper superset. As you can see, the proper subset symbol is just the opposite of the proper superset. This is because between 2 sets, if one is the subset, the other is the superset. Or vice versa. The same is true with improper subsets and improper supersets. Their symbols are just the opposite of the others. If we recall in our previous example of set A, the subset with elements 1, 2, and 3 is the improper subset of set A. And set A is the improper superset of this subset. If we denote this subset as set B, then we can write, which is read as set B is the improper subset of set A. And set A is the improper superset of set B. If we remove any of the elements of set B, the resulting set, say, set C, with 1 element less, is called the proper subset of set A. And we can use the symbol to denote this as shown. And since C is a proper subset of set A, then set A is the proper superset of set C. At this point, maybe we can ask ourselves, are subsets elements of a set in general? The answer is no. But subsets are parts of the set from which they were derived or their superset. And the reason for this is that, when you take the set apart or say, dismantle it, what you can get are its subsets. Or you can think of subsets as parts making up the set. To illustrate this idea, we recall set A in our previous example. Set A has 3 elements, namely 1, 2, and 3. So we can dismantle set A into 3 parts, and each of these parts is called a subset. To show that these are the parts making up set A, we can recombine the parts by using the set operation, which is known as the union of sets. And we showed that the 3 subsets are equal to set A, meaning that subsets are parts of a set and not elements of the set. We can therefore state that there are 2 exponent n unique set parts, as there are 2 exponent n as many subsets. To demonstrate this, let us try to dismantle set A into 2 exponent n unique parts or subsets. To begin with, let us separate the set into 2 parts. One part composed of a set of all its element, and the other part the empty set. Next, we will continue to do the same, each time with different elements combination, until we run out of possible combination. So after just 5 steps we ran out of possible combination. But out of these we have our unique 8 parts of set A, or its subsets as shown. So here, again, we have shown that subsets are parts of a dismantled set and not an element of a set. Every set with unique elements than that of another set has a set of unique subsets that differs from that of another set. In our previous example, you can observe that set A with 3 elements has a different set of subsets than that of set C with 4 elements. These 2 sets of subsets are a collection of themselves and must belong to a set. Mathematicians call this set the power set. Specifically, the first is the power set of set A, and the other one is the power set of set C. And by definition, a power set is a set that contains all the subsets of a set. This is written as or. And all of the subsets must be enclosed by curly brackets because they belong to a set or the power set of set A. And all is the same with set C. Now, these subsets become the elements of the power sets. And this concludes our video for this episode. Please support the channel by subscribing